Okay, can you hear me? Yes. I'm going to try and use this thing because I'm supposed to be talking about active learning, so I have to be a little active myself. Okay. Right, my name's Andrew McLaren. It's very humbling to be described as a giant of CDIO by someone as big as Martin, so I shall not try to live up to that too much. But my name is Andrew. I'm from University of Strathclyde in Glasgow in Scotland. And what I'm going to try and talk to you today about is active learning, engaging students in the learning by getting them to do things rather than sitting and listening. So it would be a little hypocritical of me to stand here and talk to you all the way through my 30-something slides, so you'll be reassured to know that you're going to have to do some work and to be active, and that's what I'm going to try and do. Now, I do have some introductory slides to sort of set the context, but there will be some activity for you to actually engage in, which will give you something to earn your lunch with, okay? Okay, so this is where what I'm talking about fits into the general sort of scheme of the introductory workshop. So you've heard a little bit about the integrated curriculum. I'm going to talk to you about learning, really focusing on what the students do as opposed to what I do. We'll touch a little bit on assessment, and we'll go actually back to a slide that looks very much like Christina's constructive alignment slide. This afternoon, I think you're going to start to talk about design implement exercises and activities, and we'll touch a little bit about what that means as well. So, the main objectives of this session: to recognize the importance of aligning the curriculum, teaching, learning, and assessment. Now, that's a little bit about what Christina was talking about before. Come on to that in a minute. I'm going to give you some examples of some active and experiential learning techniques that you can use with students to get them involved in the learning process and try and explain why that's important. And I'm going to get you to participate in at least one active learning process, and that will actually help me out, because rather than me go through a whole lot of stuff, I'm actually going to get you to teach each other one or two of the concepts that I'm going to cover in this talk. So this is going back to Christina's slide on constructive alignment. Okay? We know what we want the students to learn. At least we think about that, and we think about what we would like the students to learn in a particular course or module or program. So ideally what we should do is think about how the students are going to learn that. So bearing in mind the learning outcomes, we design teaching and learning activities, learning experiences for the students to go through that are aligned with those learning outcomes. There's no point in designing something which is going to get them to learn something else if this is what you want them to learn. And then the third part of that jigsaw is we also design assessment processes which are aligned with the learning outcomes. Okay, so we design the learning outcomes, we design the teaching and learning experiences and the assessment as a whole to ensure that they're integrated together. And purposely, these arrows go in both directions, that the assessment process is related to the learning outcomes in both directions. Okay? Now, we're going to concentrate on the teaching and learning activities in this talk, and we're going to look at some ways in which you can get the students involved in their own learning rather than being passive observers, not being involved at all. So it's really important to engage students. I'm sure you agree with that. It's much more important what the student does in the learning experiences than what the teacher does. If the teacher does a whole lot of exciting things at the front, but the students are asleep and not engaged, then it tends to be a waste of time. So my view is that engaging the students, getting them involved in the process with you, and perhaps more importantly with each other, is an important principle that we should try to develop in our learning. So there's a bit of interesting sort of background to this in terms of learner activity. And it's really this box that I want to concentrate on. This is what Glasser, reporting work by Biggs, suggests, okay, if a student reads something, they probably only remember about 10% of what they read, okay? If you talk to them about something, they maybe remember 20% of it. If you show them something at the same time, they start to remember a little bit more, maybe up to 30%. If they see and hear, you know, there's multimedia. Students are very good at absorbing things on different channels. They see something, they listen to something, then they're perhaps remembering half. But we only actually start to get effective memory and learning when they actually start to become active in the actual process. So for instance, if they talk to each other about a concept that you're teaching, they start to learn more, understand more. If they apply it to some sort of real application, that's even more effective. And perhaps, sort of surprisingly, but maybe not for those of us who've tried to do teaching, my experience is when I try to teach something to people, that's when you really learn it properly. If you have to try and explain it to somebody who maybe doesn't understand it, you have to learn it in more detail. So if you can get students to do this sort of process, where they have to explain to other people, preferably explain to other students, what that concept is, what that subject matter is, then I believe that's a very effective, and the research does show that that's a very effective way of engaging the students. So, central to CDIO is the idea that educating engineers, we should equip our graduates with a range of personal, professional skills. Unfortunately, traditional lectures and labs, you know, where we stand and talk and then the students go and do a laboratory which they don't really understand and then they come back and listen to a bit more lecturing, it's not very effective at giving the students those opportunities to develop these sort of professional skills. So active learning approaches try to integrate the learning experiences so that we get the discipline knowledge and the professional skills, personal skills, all in the one. And that's really the sort of CDIO Standard 7 that was being talked about previously. Now, what I'm going to concentrate on is active learning. And that's really Standard 8, which you can see in your handout. If you turn to page 10, I believe that's the right page, you'll see that the standard number 8, active learning, we have an aspiration to have a range of active learning activities that engage the students directly in thinking and problem solving. We aim to help the students to understand actually how they are learning. It's not just sufficient for them to learn things, but we quite like them to understand the processes they're going through in learning. And we want to increase their motivation and help them form habits that will inform their practice in later life. So learning about how to learn is almost more important than the subject matter itself. Learning to find out things for yourself, learning to be critical, learning to read things and then try and explain them, those transferable skills, those lifelong skills are what we're trying to inculcate in the students. Almost more important than the specific knowledge that we're dealing with in a particular lecture. So learning how to learn, I would say, is one of the most important things that we do in higher education, not just the specific knowledge of that particular lecture. Okay, so there are, I would say, two categories of learning experiences. There are active learning and there are experiential learning. Now, I'm going to mostly talk about active learning. So examples of active learning might be pairing and sharing, group discussions, debates, concept questions. I'm going to talk about some of these in more detail in a minute. Experiential learning is where we ask the students to do something relating to engineering practice and to learn by doing that activity. And good examples of that are things like design implement exercises that we're going to talk about in the next session after lunch. Okay, so I'm really going to concentrate on approaches that lead to active learning in a sort of classroom setting. Okay? Now, you'll probably be familiar with the Kolb learning cycle, okay? And what this generally says is that if we start with some sort of abstract concept, perhaps an equation or a model, okay, we can teach that in the classroom. We can give the students a bit of knowledge, we can make them read something. That in itself isn't very effective in terms of getting them to learn that in a deep way. What they need to do is then perhaps experiment with that, to apply that in some way in a practical application. Perhaps have a concrete experience, which allows them to test that knowledge against something that's real, and then to reflect on what they've learnt during the rest of the cycle, and then feed that back into their learning of the concept. Now, in general, traditional university-type courses run in that sequence. We give them some lectures, we send them to labs. They then perhaps, later on in the course, they do some sort of project, okay, where they might have to bring out from the cupboard their sort of knowledge from the lectures in second year to do a project in third year. And then they might think about it, and they might then feed that back in. Now, what I would argue is that there's no real reason, there's no good reason why you have to start at 6 o'clock, okay? You could start anywhere on this cycle, and a lot of programs, particularly CDIO programs, can start at the concrete experience. So you could give the students a project to do without having taught them anything. And they would then realize, hang on a minute, I can't do this unless I know something about gravity or electrical circuits or control, or I don't have the equation for that. Where can I find it? Okay, so they almost realize what they need to know, and then you can say, okay, well, we can help you to find that out. Okay, so there isn't a good reason for starting here. It just happens to be that that's where we generally start in traditional courses. So you could start anywhere. And this is actually quite a good place to start in a lot of instances, because the students then get it. They understand why they need to know those equations, because they've tried to solve a problem, and they realize they don't have the knowledge to do it. Okay? Now, there is a little task in here. If you had this slide in front of you, what you could do is have a look at the various titles of active learning approaches at the top and experiential learning at the bottom, and you could mentally tick off which ones you think you do in your programs right now. Okay, so you can have a little think about that. I'm really going to concentrate on some approaches in the upper half of this slide, and the experiential learning parts, particularly things like design implement things, will be talked about a bit later on this afternoon. What I'm going to do is talk about these 5. Now, you'll be reassured to know that I'm not going to talk about these 5. I'm actually going to talk about the concept questions. I'm then going to make you do the jigsaw classroom, and the jigsaw classroom activity will allow you to teach each other the other 3. Okay, so I'm only going to have to do 1, and you're going to do all the rest. Okay, and by experiencing this, you'll learn these, and you only have to listen to me for another 3 minutes while I talk about concept questions. Okay, is that a good deal? Okay, it sounds better than listening to me for much longer. Okay, so let's just talk about concept questions briefly. Now, Peter Goodhue has really done a good trailer for this for me, because he wants you all to think of a concept question. So I'll give you the spiel about concept questions, but essentially you have to be part of this process, and I promised Peter that I would plug him again, that he would like you to think of a concept question in your area that tests a concept in your discipline. So what does a concept question do? Well, to recap what Peter said, we generally use concept questions in a lecture-based scenario to check whether the student understands a basic concept in the discipline we're trying to teach. Okay, so what I usually say to students when I'm explaining what we're going to do is, when they're at school, high school, they're often in classes of about 20, probably less than that, fewer students than that, when they're in senior parts of high school, maybe 10, 15 students. The teachers know them. They understand what they know and what they don't know. They have a relationship. If you have a class of 200, it's very difficult to have that sort of relationship. So concept questions and often using technology, the clickers, the interactive hardware that allows you to get each student to answer a question on a sort of multiple choice, like who wants to be a millionaire? That gives you very quick information about what the students know and understand. So the concept question is designed to test one concept in the discipline you're trying to teach, and it asks them quite frequently a multiple choice question that tests whether they understand that concept. And you can get the students to answer that question, and you get the results straight away on the screen. Ask the audience, okay? And you can tell then whether they've got it or not. Now, there's various things you can do about that, and I'll talk to you about in a minute. So it's quite difficult, as Peter has suggested, to design these concept questions. You're trying to test one concept. You're trying to make it unambiguous, so there's one right answer. Not always easy, and sometimes the debates you have in the classroom about what the right answer is are quite instructive. We've had high school teachers of physics come in and have a big argument about what the right answer to a simple question about conservation of momentum would be. And that debate is quite instructive in understanding what they understand and what we think the students might understand when they come in, having been taught by these guys as well. So here's an example of a concept question. So I'll put you on the spot. If you have a think about that, this is a question that tests a basic concept to do with aircraft. I believe there is one best answer to this question. And this is the sort of question you might put up in front of a class. And you would ask them, what do you think the right answer is? So we give them some time to think, and then often we'd use a bit of technology where they have to push a button, or you could do it by shows of hands, but that's not quite so effective because then they look around to see what other people are saying. They're very influenced by peer pressure and conformity, and they don't necessarily see the right answer if they're looking around to see what other people are doing. So finding some way of using a bit of technology or possibly little cards that they hold up like this to indicate what they personally think the right answer is without having to feel self-conscious about it. So, anyone fancy telling me what they think the right answer is? That's unfair, isn't it? Okay, I think the right answer is 5. Okay? You basically, if you want a plane to fly as far as possible, you need to use up the energy as slowly as possible. So you need to minimize the amount of power required. Yeah? You might want to disagree with me about that, but... So, the question is, you ask the question in class, you find out what every student thinks. It maybe displays it as a graph on the screen. Okay, I think that's the right answer. So what do I have to do? What do I have to do after I've asked that question? That's the important bit, okay? Let's say 25% of the students think it's answer 5. Well, it's a little difficult then to believe that the whole class understands that concept. So what do I have to do? Can you think of something I could do? Yeah.
Ask the students why they ask the students to explain why they minimize power because they are 95% learning.
Yep. Okay. So you could actually ask somebody, right? Okay. Say I could say to you, okay, who said 5? Okay, and you might get a couple of hands go up. You say, okay, well I agree with you. That's the right answer, I think. Do you want to explain to the class? That does work, and I have done that from time to time. Often we find that's a little intimidating in a class of 200. What we often do is a sort of paired peer instruction type activity. So instead of asking you to explain to the whole class, I might ask you to explain to your neighbor. Tell them what you said, find out what they said, debate it, then maybe ask the whole class again and see whether it changes the understanding. What I could do is give a little mini lecture about the concept. I could give them a bit of information. That may be necessary if a very small proportion of the class are getting the answer right. We listened to Eric Mazur last year talking about this technique, and he says you're looking for about the right proportion of students to get it right. If 100% of the class get it right, the question was too easy and it's a waste of time asking it. If nobody gets it right, it's too difficult and it's a waste of time asking it. What you want is somewhere around half the class to get it right, and then the chances of you sitting next to somebody who got it right, if you didn't, are quite high, and you can have a constructive dialogue then about what the right answer is. What we often find is that students explain much better to each other a concept that they've just understood than we do to them, who maybe understood this years ago, okay? They talk a different language quite often, not just, linguistically, but they come from a different place in terms of where they are. They can explain things more effectively than we can to each other. So I think the important thing about this technique is what you do after you've asked the question and actually getting the students involved in that dialogue. Okay? So you want to see things moving forward. It does mean you have to be flexible when you use this technique, and having to sort of go through a set amount of material in the lecture is something you perhaps have to park and be prepared to sort of step away from. That if you get the students to understand one or two concepts well in the lecture and use pre-reading and work outside classroom to deliver the knowledge, then this is an effective technique. If you regard the lecture as an opportunity to pour knowledge into the students, then this isn't going to help you very much because you're just not going to get through the material. Okay, so you need to think about how you're going to use this technique. So for instance, we've gone to 2-hour blocks instead of 1-hour blocks, and that gives you more flexibility. And we ask the students to read a chapter of a book before we get them to come. So they've got some pre-idea about what we're going to talk about. And then we use the classroom time for this sort of activity, which engages the students, rather than the first time they've seen the material. So it's really, it requires a bit of thought. Okay, so moving on. Jigsaw classroom, right? This is where you get to do something. So this is a cooperative learning approach where you cooperate with each other. So it's not so important what I do in this, it's what you do. So what you're doing is effectively forming a contract in teams to teach each other the concepts that we want to learn. Okay? So you have to take some responsibility to read and learn a particular concept and then explain it to your peers, to other people in your group. Okay? So I'll explain how this actually works. What this does is it addresses that bottom line of that box that I put up where what percentages of students learn certain things. We're right at the very bottom. If you have to teach something to somebody, you learn 95% of that material. You remember 95% of that material. So what you have to do is get the students to start becoming the teachers, becoming the explainers of the thing that they've just learned. Okay, so this works, I mean, as you're going along, we're sort of starting to help students to communicate and work in teams, but it's also very effective at getting them to understand concepts. Okay, it's also quite an efficient way to cover content, as you'll see in a minute, because I'm going to shut up in a minute and you're going to teach each other 3 other concepts. Okay, so let's say you had 4 concepts to teach, okay? 4 topics that you wanted to cover in a lecture, okay? What I would do is prepare some briefing notes on each of the 4 concepts, and I would give them out to the students. I'd get the students to form into groups of 4, okay? And they would number themselves in those groups, 1, 2, 3, 4. Okay, so you'd have a group of 4 people, 1, 2, 3, 4. I would give each student in the group a particular concept. So all the number 1s would read about concept 1, perhaps overnight before the lecture, and all the 2s read about concept 2, and so on. So they would do some pre-reading. They would study the material first, but only one topic. We then get them back in the next day, and the first thing we do is get all the 1s to cluster into groups of 1s. And they then talk to each other about their concept. So they're sort of experts. They've learnt this particular concept, and they talk to each other about it, and they reflect on how most effective it would be to share that, to teach that to the other people. What are the main points I've got to get across? How am I going to explain it? So they're little expert groups. They then go back to their base groups, okay, which is the group that consists of 1, 2, 3, and 4. The number 1s explain their concept to the other 3. The number 2s explain their concept to the other 3, and so on. Okay? So this is the students doing the instruction, having had the reassurance that they've discussed it in their groups. And then when all the groups have learnt the concepts, we then do some sort of checking to see whether they understand or not. Because it's my responsibility as the teacher to check whether they've understood it. I can't just leave it to the students. I've got to take responsibility. So I have to take control back at some stage and find out whether they've learnt it or not. And we'll talk about that in a minute. Okay, so this is where you get to do it. I want you to form groups of 3. I have 3 concepts to teach, so I want you to form groups of 3. And I want you to number yourselves in the groups 1, 2, and 3. And the briefing notes that I've got are in your handout. Okay? So, page 16 and 17, okay, describe 3 teaching methods. Okay? Page 16 has method 1, and it has method 2, and page 17 has method 3. Right, so in your groups, okay, I want you groups of 3. I want number 1 in the group to only read method 1. Don't read the rest. Please don't read the rest. That's not your job, okay? Your job is to read method 1 if you are number 1 in your group. If you are number 2, only read method 2, which is bottom of this page, top of that page. And if you are number 3, only read method 3. Okay, now, that's all I want you to do at the moment, is read that section. Okay, and I'll give you 5 minutes, okay? 5 minutes to read that section. It's about half a page each. Just read that section and study it. The big decision is, are you 1, 2, or 3? That involves moving around the room and all the ones getting together in clusters of 3 or 4, okay? Now, we can't do that today. I mean, you're going to be too hungry, okay? I've already only got 5 minutes left, so you'll kill me if you don't get any lunch, okay? So we're not going to do this today. The benefit of that is you would have a chance to discuss your concept that you know with other people and reinforce the lessons with other people who've also studied that. So what you're going to do is, in your base groups, the ones I want you to briefly explain your teaching method, your active learning method, to the other 2 people. And the 2s and the 3s. Okay? So you can now talk to each other. This is where it gets a little noisier. Explain your concept to the other 2 people in the group. And then swap round. And spend a couple of minutes, just 2 minutes on each concept. Okay, folks. Right. I'm sorry to cut this short, but you'll be hungry. Okay, so hopefully you've each had a chance to explain your teaching method to other people, and you've heard 2 teaching methods explained by colleagues. Okay. So what I like about this technique is it's not my job to lecture. Okay? I get you to read. You know, you're intelligent people too. The students are in control of this learning process. They then explain to their colleagues, and it helps them to teach themselves while they teach each other. Now, it is important to check what learning has occurred. So, how do you think I could do that? How can I check whether you've learned anything in the last 10 minutes? Right, okay, starting now. You'd rather have lunch though, yes? So, think of another technique. What else can I do now with you to find out whether you've learned anything?
Concept question.
A concept question. Okay, right, so here's a concept question. Which of these active learning techniques that I've got you to teach each other clarifies and reinforces independent learning through peer discussion? Number 1, okay? Most people learn 70% of what they talk over with other people, okay? So there's some advantages of this. Everybody is thinking about the question, okay? They get the students who do this sort of formulate, share, create, and revise. They get to test their understanding of that concept with one or two other people in a sort of private huddle before they have to explain to the rest of the class. Okay? So it stimulates valuable group discussion. Okay, so which active learning technique that you've just learnt about motivates students to spend more time in private study by requiring them to explain their learning to the class? 3. Okay, fantastic. Recitation and ticking. Most people learn 95% of what they have to explain to others. So if you have to come up here, you know, you've signed up for this, that's okay. You know, you said, okay, I think I can understand and explain concept 3, okay? If I say to you, okay, who 3, okay, you come up, explain it, okay? The chances of you getting chosen are not very high, but you're pretty sure to be ready for anything you've ticked, okay? So it generates time on task. Possibly it's the fear of being chosen that drives people to actually read the stuff they've said that they can actually do. If they think they can explain this particular example, and they've said, all right, I'm happy to do that one, they'll make sure they jolly well can explain it, and they're ready, okay? The other thing is that it helps the students understand some sort of criteria of quality. They see good explanations of particular concepts or problems, and they see not such good ones. And they start to be critical about their own quality of understanding by observing peers attempting to explain a concept in front of the rest of the class. So it helps them to be critical about their own learning and the quality of their own explanation. Okay? It also gives immediate feedback to the students. We have a thing called the National Student Survey in the UK, and the students who are just about to graduate are asked all sorts of questions. They're asked about the quality of feedback and assessment that they get back from their teaching staff. It's always bad news. It's, you know, they don't like it. They don't think they get enough feedback. This is a really good way of giving instant feedback to students in the classroom about the quality of their own learning. This is what the students say about recitations, okay? I won't read those out, you can read them. So sometimes observe that they actually see friends who generally aren't very strong students suddenly get it, suddenly realize what the concept is. Okay. So which of these active learning techniques encourages students to reflect on their learning and provides immediate feedback to the instructor? Well, it must be number 2, mustn't it? Okay, so what I could have done right now, if we'd had little post-it notes, is asked you, what is it about what I've just done in this last 45 minutes, an hour, that you still don't understand? Okay? So I could have got you to write on a piece of paper, and you can still do that if you want, something that you don't understand, or a bit of feedback that you want me to take on board, and you can leave it with me as you go. Now, we can do that with students. We can say to them, right, here's a post-it note, here's an index card, write one thing down that you either didn't understand or want to give feedback about, and leave it with me as you leave, anonymously. Okay? And you can do that. The good thing about that is that you get instant feedback from the students about the effectiveness of what you're doing. The important thing is you've got to act on what they give you. So if they say, I didn't understand the whole bit about recitation, okay, and you take that in and you read it and go, okay, fine, and then you don't do anything about it, they just lose all confidence in that process. What you've got to do is take some action. Next time you come back and say, right, okay, I got the following feedback, broadly broken down into 3 themes, so I'm going to spend the first 15 minutes of the class next week going through those things, doing some active stuff with you to help you to understand that. You've got to be a partner in that process. So the good thing about mud cards is they give you some information quickly, but you've got to do something with it. Okay? Otherwise, the students will say, what's the point? Okay? So if you have any feedback you'd like to give me, if you want to write it on a piece of paper, leave it as you go out on the table at the back, please do so. Okay, thank you. You can go and eat food now.